Let's look at exponents and exponential notation. Essentially, what we want to do is take a number and multiply it by itself several times. But that can be long to write out, so we don't always want to write that out. So we have an abbreviated notation to represent this. We have this a to the nth power. This essentially means we're going to multiply the number a by itself n times. And in order for this to work for now, we're going to assume that a can be any real number you can think of, but we want n to be a positive integer. The number a is called the base, and the number n is called the exponent. So let's look at a few examples of how these work before we start getting into some of our rules. The first one I have is 1/3 to the 4th power. So this means we're going to multiply 1/3 by itself 4 times. When we multiply fractions, we multiply the top and then over multiply the bottom. On the top, I have 1 times 1 times 1 times 1. And on the bottom, 3 times 3 is 9, times 3 is 27, times 3 is 81. So 1/3 to the 4th power is 1/81. Next, let's look at -2 to the 4th power. So this time we're going to multiply -2 by itself 4 times. When we do this, we have -2 times -2, which is 4, times -2 is -8, times -2 is positive 16. Let's look at one more. -2 to the 4th. This time we're multiplying 2 by itself 4 times, and then we introduce the negative sign. The negative sign, since it's not in parentheses, should not be included all 4 times. When we multiply 2 by itself 4 times, we get 16, and then we have this negative sign out front. So this time our answer is -16. When we're working with exponents, there's several rules that we can use. And let's look at one in particular called the multiplication rule. 3 to the 5th times 3 to the 4th. How can we combine these to be just one exponent? Well, let's start by thinking about exactly what this is. 3 to the 5th means multiplying 3 by itself 5 times. 3 to the 4th means multiplying 3 by itself 4 times. And since order of multiplication doesn't matter, these parentheses don't really matter. And we can see that total, there are 9 3's here. So this is 3 to the 9th. Or 3 to the 5 plus 4. And in general, this is how the multiplication rule works. If I have the same base and 2 different exponents and I'm multiplying, I can just add the exponents. A to the m times a to the n equal to a to the m plus n. I want my multiplication rule to be true no matter what m and n are, if they're any integers. So I've said that we only wanted to deal with positive integers, but what happens if we try to include 0? Let's think of 3 to the 0 times 3 to the 4. Our multiplication rule that we just looked at said that we add the exponents. So that's the same thing as 3 to the 4. Well, if 3 to the 0 times 3 to the 4 is equal to 3 to the 4, essentially I multiplied something by a number to get itself, which tells me that 3 to the 0 has to be 1. And in general, that's true no matter what. As long as a is not 0, a to the 0 power will be equal to 1. So that told us how to deal with 0, but what if we have a negative integer? What if we want our exponent to be negative? How will that affect things? Let's think of 3 to the 4th times 3 to the -4th. My addition rule says I would add these exponents, so 3 to the 4 plus -4. And 4 plus -4 is 0, and we just said 3 to the 0 is 1. So essentially I have 3 to the 4th times 3 to the -4 is equal to 1. And if I divide both sides by 3 to the 4th, I get that 3 to the -4 is 1 over 3 to the 4th. And once again, this is true, no matter what value of n I have. A number raised to a negative exponent is the same thing as saying that that number belongs on the bottom of a fraction. So let's do a couple of examples using these two rules. My first one, 3 to the 8th to the 3/8 to the 0 power. Anything to the 0 power will always be 1. It doesn't matter what your base is, we'll have a 1 there. X to the -2. A negative exponent means it should be pushed to the bottom of the fraction. So 1 over x squared. -3 to the -4. Well, once again, that -3 needs to be pushed to the bottom of the fraction to make the exponent positive. -3 times itself 4 times is positive 81, so this actually gives us a value of 1 over 81. And in the next video, we'll delve in a little bit more to the multiplication rule and introduce a few more rules for working with combining exponents.